Hi, we have here two radios FRS and the transmitter, and we will make a remote control with the FRS radios. First of all, we need a microcontroller or oscillator, whenever. And for example, this is a peak, and it only sends uh, the frequency of 1.4 kilohertz. Here, when the pot we control the modulation, and then we send them to the microphone of the radio. And we use this relay only for use like a PT. In the radio, we need just two resistors of 10 kilohertz, and when we connect it, and the resistance this point to this point, and the radio start to PT mode, and we send the signal of 1.6 kilohertz to the radio, and we transmit in channel 1. Okay, the second radio receives the signal, and for the speak out we have here is cross it passed to the circuit integrate, that is the NE567. Is this one we have here. Okay, and I will this is the secret word. This is the secret, and we made this circuit that is here. Yes. Okay, here we put the input of the signal from the radio, and for R1 I use a 10 kilo ohms precision resistor, and for C1 I use a 100 nanofarads, and the C2 it has one capacitor of 2.2 microfarads, and for C3s I use a 2.2 microfarads, and either of those is a 100 kilo ohms, and the RL is the charge. Okay, and this chip, the thing that is does here we have in the data sheet of Philips is that when he detects the square wave, the signal, I don't know, the frequency that is tuned for, the output has a 1 or 1 0, and it has a lot of immunity to the noise. They have the formulas for calculating. Okay, so now we start to oscillating that circuit. Okay, now we will make a test. For this example, the output of this goes to one LED and one opto isolator, and he goes to a relay that starts the bell. Okay, we energize the circuit first. We energize the chip, and we energize the bell or the ring, whatever. So, okay. So in this case, we start the transmission with this spin. Okay, and you see anything happen. The relay start to transmit down, and the receipt, but I didn't inject the tone right now. Now I will connect the tone input and look what happened. So it can be used like a remote control, just one oscillator, just one chip, or just one radio. We can make more complex this stuff because this chip gives us the ability to send bytes or data to from the microcontroller in form like a tone here, and we transmit in Arabica to this radio, and we can decodify with another microcontroller. We can send a package of data, and we can use those to detect it. This circuit is very precise. It has a voltage controller oscillator that get tuned to the frequency of the oscillator that he received. Okay, I will disconnect this. Okay, so for get a finest tuning, I use a frequency counter. The frequency counter I use it, I I connect. Wait, pause. Okay, for get a good tuning of the frequency, I use a frequency counter like this one. I put it in the channel of 10 hertz to 10 megahertz and low sensitivity, connected to the ground and the signal from the controller. And now I can see the signals here. I'm sorry, I mistaken the frequency. The frequency is too high, but it still work. Okay, these radios, I don't know sure the bandwidth for the voice. It's about 2.5 kilohertz. It's a little bit high for that. It's just to be 1 kilohertz will be enough. Okay, so I know that the frequency from the controller is 2 kilohertz point 47, 2 kilohertz and 418, 18, whatever. This is the frequency. Okay. For tuning for tuning this circuit, I use do this. Okay, I put it the ground, and now I connected. I connected in the point of C2 in the pata in the pin 5 6 in the pin 6. And I put it into it. Okay. And now I am reading the lecture from the BCBO. You know it's very precisely. So I need to put the input, the pin number 3 to the ground for the reason that the BCBO won't get a lock phase, a lock cycle. So I use this and I see it. That is the frequency that is programmed to. The voltage affects the frequency. I change the power supply for the reason get this calibrate. I want to calibrate this. It's like a 2.4. Get low. Okay, you see it. And now closest to the range. Okay, now it's tuned. There's voltage control oscillator of this chip with the emission, with the transmission tone. I get locked. Okay, I'll now get back the pin to the radio normal operation. Okay, it's just very handful because you can be sure that the frequency that you use it, because you have the tools, you have everything. Okay, now a little closest look of the connections. Okay, we get here from the speaker of the radio. Just one jack with 2 pins. They had the third one. I didn't use it. The biggest one is the ground. I put it to the ground. The last one, the signal is the point, the point of the radio. Yeah, you will see very hard. And I have a capacitor of 100 nanofarads, and I put it here to the configuration that you can hear below. Already I give you the values that I use it. It's very important to get the correct values. The tuning frequency is important. Also, the C2 and C3. If you put a very high value, it won't work. For this reason, I will repeat: C1, C3 is 2.2 microfarads, C3 is 2.2 microfarads, and C2 is 1 microfarads, C1 is 100 nanofarads, and the resistance is a fine-tuning resistor of 10 kilohertz, 10 ohms. So, I will show you again the operation that is very, very precisely, and I didn't get the range now. For the moment, I just using a short distance, but it were very good, a very good range. And so the only thing I need is to start the transmission, with this. Start the transmission and the relay. One get the transmission. Also, I can get speak and hear for the radio. Okay, and the time that I get to transmit the tone, it will turn up because it's detecting a loop, again a phase loop look at that frequency and will detect that frequency. Yeah, so it control can be done by a different tone and some few circuit like this. It's a very easy to build and tune system chip, and we can make doors or wherever we can work it, because these radios are very cheap and handle, and I try to get a one way to communicate and send data. The second project I will do is to send a package of bits from the microcontroller to the radio and receive them in here. This is a very combination of because the for practical understanding of what I'm doing, because we can send a bits like a 1 or 0 in the radio waves. The thing that I use is a tone that transmit. If the tone is present, we can set 1. If the tone isn't present, we can send 0. And if we can switch in the tone and the tone, and we can send a package of 8 bits, for example, and we can communicate back the radio to the radio, and we can get a powerful, very long range data transmission for a very cheap cost. If you have some answer or some question about this video, just write me in the YouTube, man, and we can use also this technology can use for a lot of stuff. It was very easy to build. So I suppose that information will be for enthusiasts and hobbyists. So we have it. Okay, I will repeat what the circuit is. The circuit is this one. We can buy it for $1 or less. It's a very cheap. Look, this circuit is special for doing this. Here we can here in the application. Look, the application saying touch one tone decoding, current remote controls, ultrasonic controls, communication paging, frequency monitoring and control, wireless intercom, precision oscillator. Also, we can make a lot of stuff. Like for example, I would just like it. One application that came here. Okay, let's a second. This one for domotics house, or we can make a light that will turn it. We send the information in a formula tone in the AC line of our house, like a 107 to 127 volts. We can send a tone that will get to decoding in one disk, and we activate a light or a relay. This circuit has the ability to manage 100 milliamperes in the mode of sync. So if we can automatize a house, we don't need to put more cables. The line of AC line 127 volts we can use like a data transmission line, like when this stuff, and we can make a lot of stuff here. Decoding, multivibrated. When the circuit will maybe you will ask why I didn't use a DCP microcontroller for making this project. We can use one microcontroller and two other microcontrollers here, but the recognition or a tone in a microcontroller with analog input will be a very, very profound theme. But we can use just for practice an easy building using a circuit like this. A DCP Each will be much cheaper or better or powerful, but this is for hobby enthusiast stuff. So I will like you will like to this video. Um, okay, this is a very hundred practice. I will show you what I did here. I have the relay, and this relay is activated for this transistor. When the relay is activated, I make a bridge between this point and those two resistance. And when the voltage getting low here, the radio understand that is ready for speak. Okay, it's something like this. Something like this. You can see here the resistance. It is for in this. I use a 4 resistor 1 kilo ohm and this relay, and you speak here and you put the radio FRS in the mode of transmit. This is a radio Milan X talk, very good radio. But I see when the battery getting low, you will need to put less resistor. So and then for this moment I use just two resistor 1 kilo ohm, like that gain us for result 2 kilo ohms, and it worked very good. With this pot, I control the modulation, the level of volume that I'm with modulating here. Okay, this is very handful, and I'm a hobby when that we like to invent something. Well, they can make a very powerful interface. If you don't know how to program a microcontroller with a problem, you can use a oscillator like the 555, and you can make a lot of few commands, just making different circuits like this one, like a 1 2 3, and we can make a configuration. If you are a computer, you don't know how to program the peak. The peak is just for send a square wave. That is the frequency that I give you, and in this frequency counter that I bought a few years ago. I use this configuration. It worked very good. Okay. Okay, see you then, and good for intention, and good luck making your remote control with your FRS radios, and you can make a very powerful stuff with the cheapest radio we can buy. Thank you.